Hi guys, in this video we're going to look at very simply how the strength of the forces of attraction in certain compounds affect their melting point, boiling point, and solubilities. So I'm going to fill in this information in point form as we go along. We're going to start by looking at three different types of substances: metal, ionic, and simple covalent. And let's look at the forces of attraction found in each type of substance. And I will reflect on its melting point, boiling point, and electrical conductivity before we move on to our second table, which is on solubility. So in a metal, there exists metallic electrostatic forces of attraction between the delocalized sea of electrons formed when metal atoms contribute their valence electrons to their crystal lattice and the corresponding cations that are formed. These forces of attraction between the cations and the sea of delocalized electrons gives rise to a type of force of attraction called metallic bonding. Metallic bonding is considered to be a strong force of attraction. Because it is a strong force of attraction, this means large amounts of heat energy are required to break these forces. So metallic substances or metals have high melting points and boiling points. Can a metal conduct an electric current? Yes. Now, due to the presence of the sea of delocalized electrons, these electrons can carry an electric current. Next up, we have an ionic compound, which is considered to contain strong ionic forces of attraction. These ionic bonds are a result of electrostatic forces of attraction between cations and anions. Because ionic bonding is considered to be a strong force of attraction, ionic compounds also have high melting points and boiling points. A lot of heat energy is required to break these bonds. In the solid state, the ions are held in fixed positions within a crystalline lattice. Therefore, they are unable to move and carry an electric current. If, however, our solid is melted into a liquid, the ions are now freed from the crystalline lattice and are able to conduct an electric current. If our ionic compound, which readily dissolves in water, does so, its ions are also freed from the crystalline lattice and are able to conduct an electric current. In a substance which is considered to be simple covalent molecules, or in a solid state called a molecular solid, it contains two types of forces of attraction. One is strong intramolecular covalent bonding, and these strong intramolecular covalently bonded molecules are said to be held together by weak intermolecular forces of attraction, right, which we call induced dipole forces of attraction, or you may know them as Van der Waals forces of attraction. Does a simple molecular solid or simple covalent molecules, do they have a high melting point or boiling point? Think of oxygen gas, carbon dioxide gas, wax. They all have very low melting or boiling points. This is because low amounts of energy are required to break the weak intermolecular forces of attraction between the molecules. We do not break strong intramolecular covalent bonding in a simple covalent molecule. This will change the chemical nature of the substance. So we are only breaking apart the intermolecular forces. Can these simple molecules conduct an electric current? No. There are no free ions or electrons to conduct an electric current. Let's take a look at the solubility of some of our compounds in polar or non-polar solvents. I'm going to start by mentioning the name of at least one polar solvent and a non-polar solvent. So for example, our universal polar solvent is considered to be water, and a non-polar solvent could be toluene or even tetrachloromethane. Right, these are both organic solvents. Let's look at the solubility of our substances. Will an ionic compound dissolve in a polar solvent? Yes, it will. For one substance, for example, a solute, to dissolve in another substance, which is our solvent, there must be some sort of solute-solvent interactions. There must be some sort of forces of attraction that can develop between the solute and the solvent. Ions having full charges and water molecules having partial charges, they are able to form some sort of ion-solvent interactions, which allows an ionic compound to dissolve in a polar solvent. So there are some sort of electrostatic or ion-solvent interactions which occur. Can an ionic compound dissolve in a non-polar solvent? No, it cannot. There are no possible ion-solvent interactions. What about a simple molecular compound such as wax, oxygen gas, carbon dioxide gas? Can these compounds dissolve in a polar solvent? We're going to consider them to be insoluble in our polar solvent and soluble in a non-polar solvent. In simple molecular compounds, we have induced dipole, intermolecular forces of attraction, and these forces of attraction can form with a non-polar solvent but not a polar solvent. So I'll leave it at that very simply, and we'll look at two other substances which are also considered to be solvents, which is acetone and ethanol. Acetone is the local name, and you know it as the active ingredient in nail polish remover. Its chemical name is propanone. Now, acetone or propanone is said to contain both polar and non-polar groups in its chemical structure. So that means it will be soluble in both polar and non-polar solvents. Ethanol consists of a non-polar hydrocarbon portion to its molecule, as well as a polar OH group. Ethanol, as such, can dissolve in a polar solvent, right? Its polar OH bond will form interactions with water molecules, and its hydrocarbon portion of the molecule will also form interactions with a non-polar solvent. And this is my very short explanation of how the strength of forces of attraction affect the melting point, boiling point, and solubilities of certain substances.